Hey there, welcome to lesson 1 of Algebra 1, solving one-step linear equations. Pretty excited for us to get started with this. So I'm creating my own Algebra 1 course. That's my goal right now. So I've got Unit 1 is all about solving linear equations, and at first some of this might be familiar from pre-algebra. Like, it's quite possible you could skip this lesson entirely depending on how well you did in pre-algebra, but I encourage you to just sit and try to absorb. I have a notes page on my website that I'll link down in the description that you can go to and print off and follow along, and it gives you some good practice on notes and following along and that sort of thing. But I'm also hoping to kind of give a good foundational perspective on how solving equations work with these really simple equations that then we can build on once we get to more complicated equations. So get ready. Here we go. First thing I would love for us to do is actually a warm-up here. And on this, the idea of a warm-up is both to just get your head in a math mindset, but also a lot of times it has a direct tie-in into what's going to be happening on the lesson. So not all the time, sometimes it's just a way for your teacher to basically encourage you to get in and start being quiet and that sort of thing. But I always try to make it connected somehow to the lesson that's about to happen. So you might have a sense of foreshadowing coming up here. So check out these questions. We've got basically words that are describing some math that's happening, and we're supposed to be trying to figure out the answer. So if you would like to pause the video and see if you can come up with the answers, I think that's a great idea. So I'll wait here. Alright, let's go through these and figure out the answer. So number 1, what number plus 10 equals 14? So think about that. We've got something that when we add 10 to it, we get 14. Do you know what the answer to that is? It is 4. Number 2, what number divided by 2 equals 8? Okay, so you gotta think in your head, got a number, I'm dividing it by 2, it gives me 8. So something divided by 2 gives me 8. That's gonna give us 16. So that would be our answer. And notice we had this word plus, we had this word divided by, or words. We have these words equals, that all of those are telling us operations that we should be doing. So that's super helpful to be able to translate that math talk into, or translate English words into math. Yeah. Number 3, if the sum of a number and 7 is 11, what is the number? Gotta love when 7 and 11 are put together because they rhyme and because there's a, yeah, never mind. So something, we're talking about sum, so that's addition. So we have a number and 7 added together is 11. So what does it take to get from 7 to 11? How many is between there? That's also 4. Coincidence? Yes, entirely. I did not mean to have that happen. So that's our warm-up, and this is going to lead us directly into our topic of the day, which is solving one-step equations. Now, before we get too far into this, let's actually talk about what an equation is, in case you're not super familiar with that term, because it's going to be kind of a big deal for the rest of math, and in particular, any class that starts with the word algebra. So an equation happens when you have two expressions that have an equal sign between them, and it's showing that this thing that's on the left side of the equal sign and the thing that's on the right side of the equal sign, that those are equivalent, that they are things that are replaceable. So kind of like if I had my name equals mom, those are interchangeable, right? Because I have my own actual name and then I have the name that my child calls me. Those are equivalent names, sort of. That's not necessarily a great example, but it's this idea that we want to show that this equals this, so we put an equal sign in between and it becomes an equation. So another way of saying that, a statement that says two expressions are equivalent in value. So the warm-up, those sentences or statements were actually giving us two expressions and saying that they were equivalent in value. If you're unfamiliar with the word expression as well, an expression in math is just a collection of numbers, letters, operations that don't have an equal sign. That's the big difference between an expression and an equation. And then equations are kind of a big deal in algebra, so be prepared to see a lot of them. There's so many equations. It's just basically all of algebra just about is equations. All right, now that we know what an equation is, what is a linear equation? So the word linear there refers to equations that can be represented by a line. So that should be an easy connection to make because the first four letters of linear is the word line. And there's ways that we can tell by looking at an equation that it is actually a linear equation, that we could represent it with a line. And we will look at how the equations go with lines more in the next unit. We'll actually do this thing called graphing, where you make equations show up visually, but we're not quite there yet. We're going to do a bunch of solving first before we get there. So the way we can tell just from the equation that what we have is linear is that it needs to have at least one variable. Otherwise, I mean, I guess it could be an equation if it doesn't have a variable at all, but that isn't an equation that would be very helpful to us, at least not in algebra. So it needs to have at least one variable, but it can actually have a whole bunch of variables, different letters, and still be considered linear. The most important thing about those variables is that they all need to be to the first power. And the interesting thing about that is that when variables or numbers are to the first power, we don't actually write their power, right? So if you have an x in your equation, it's to the first power, even though we don't write that one there. And that has to do with the fact that mathematicians, as well as all of humanity, are lazy by nature, and so they don't want to have to write more than necessary. And the one that is the exponent, as well as the one that would technically be the coefficient or the number in front of x here, we don't normally write those unless we need to write them for our own understanding for some reason. So if you see an equation that just has x without an exponent, it is to the first power. So what would tell you that something was not, in fact, linear would be seeing something like x with a 2 after it. That would make it not linear. Another thing that could happen is having an x on the bottom of a fraction instead of on top of a fraction, or really anything else that seems particularly weird. Like having 1 over x does not represent something linear. Or having a square root sign and having an x inside of that, that is not something that is linear. So we're just not really going to encounter those things much yet, or maybe not even at all this year. X squared, yes we will. But those other two situations will be a lot farther down the road for us, so that it should be fairly easy, hopefully, to see, okay, x or y or whatever letter I have, since it's not to a power and it doesn't look funny, then this must be linear. And why we care so much about linear equations is they are the simplest type of equations, so we're going to learn about them first. And the rules that we apply to linear equations also are the rules that apply to all other equations, and so it's going to help us build a foundation of knowledge that then we can apply to other types of equations as well, which is really helpful. Also, lines and linear equations come up a lot in the real world. There's tons of things that can be represented with a linear equation, and what's really funny is that whenever people are modeling actually really difficult things that are not lines, they'll sometimes actually still try to use lines to represent them just because of how much easier it is to use lines than anything else. And that idea is that if you have something that's a curve, for instance, like the Earth, and you zoom in really far on that curve, if you zoom in far enough, all of a sudden it looks not curved. It looks like a line. So the same idea there, that we can take relationships that are not linear, that are very curvy, and if we just look really, really closely at them, we can still actually think about them as a line. That's probably more information than you needed right now, but that's okay. Let's actually look at some equations. As I mentioned earlier, I've got a website with resources, and so if you would like to be following along with this without having to write everything down yourself, please head over there, link in the description, and you can print off a nice looking notes page for this. It's really important as you're doing math to write things down. There's some muscle memory things that happen that there are studies that show that writing things down and taking notes helps you remember things more than just sitting and absorbing. There's also the idea that you could look back at your notes and use them to help you complete assignments or to study for tests and things like that. And just in general, it's a really good habit. As I go through this, am going to attempt to mimic what I actually would do if I was solving it myself. I'm going to attempt to think out loud and hopefully help you realize what you should be thinking as you do these problems. And so by getting in that mindset of sitting here and writing down as I write down, that can be super helpful. I say all this, and this first example maybe doesn't have a lot to write down because we are starting off with kind of the simplest equations that are possible to solve. So as I look at these, there's more than one way to do this, and I actually want us to use mental math. So just like what we did in the warm-up, I want us to sit and think about the answer. So as I look at A, like point A, like the first equation, which is labeled with an A, it says x plus 3 equals 9. And so in our heads we could think, okay, what's the thing that should be there? Variables are representing a number. We may not know what that number is, but that's the idea. There should be a number where x is that makes this make sense. So what plus 3 equals 9? And hopefully, through thinking about that, you can pretty easily come up with the answer, which is 6. And we'll just go through the rest of these and see if we can do the same thing. So, because it's an equation, actually, we'd write x equals 6 to say, hey, you asked me what x is, and now I've told you x equals 6. On B, a minus 2 equals 10. So there's a number that we should be able to put here that when I subtract 2 from it, gives me 10. So think about it, and if I'm telling you the answer too quickly that you need more time to think, then make sure to pause the video as we're going along. If on the other hand I'm going too slow, there's a cool feature on YouTube where you can speed videos up so that I could be a lot faster if that's what you're into. So something minus 2 equals 10. That should be 12. Alright, let's look up here at C. When these are right next to each other, this is indicating multiplication. So 4 times y equals 20. 4 times what gives us 20? That would be 5. And this last one might be the hardest just because it looks like a fraction, which is intimidating. But what number, when you divide it by 5, equals 6? The answer to that is 30. Now, how difficult those equations were may depend on just how good you are at mental math, or it may depend on how long it's been since you did math, or things like that. But I think most of us who are at an Algebra 1 level of math should be able to, by exerting some amount of mental work, should be able to say, okay, I can figure out what number should go where this variable is. But these are the simplest equations possible, and they definitely get harder in such a way that maybe it's not always a great idea to try to just mental math your way through an equation. And so what we have are some really great algebraic properties of equality that we can use to help us figure out how to solve an equation. And they're all very similar. And since you're in Algebra 1, I'm assuming this may look intimidating, this slide, especially the middle where we've got a whole bunch of letters and no numbers. And what I want to encourage you to do is not stress out about whether or not you understand it. Listen though to my explanation, because throughout math, your textbook or maybe the notes your teacher gives you will have things that look like this. And I think the best way to start getting used to and understanding what they're trying to tell you is by continuing to be exposed to these sorts of things, hopefully with somebody there to explain what's happening. So these properties of equality go with each of our operations that we know and love, that we've been learning about for the last however many years that we've been in school: addition, subtraction, multiplication, and division. And each of these properties is actually saying a very similar thing, that if you have an equation, so in all three of these on the middle column it has if A equals B. So if you have two things that are equal, then, and then the next part is a little different on each, but each of them is saying as long as you do the same thing to each side of the equation, what you have is still an equation. So think about what that means. If you have an equation and you decide to just put a number somewhere in that equation that wasn't there before, you no longer know that those things are equal. In fact, they probably are not equal anymore, unless you add 0. You can add 0 as much as you want. But because we have these relationships we're showing that this equals this, if I just decide to put an extra 4 somewhere, that completely changes what's going on. What this is saying is that if we do that thing to both sides of the equation, then we still have the same equality as before. And that gives us this last column that can maybe be an easier way to think of it. So the addition property of equality says you're allowed to add a number to both sides of the equation. The subtraction property of equality says you're allowed to subtract a number from both sides of an equation, and so on and so on. There are other properties of equality as well, I think. I feel pretty confident about that, but these are the ones I wanted us to look at least right now. So now that we've talked about this, we're going to go back to that example and we're going to think about how can we use these properties to solve instead of just using mental math. So those algebraic properties of equality can help us here by helping us figure out a way to actually isolate the variable that's happening. That's a word that we use a lot in math. We want to isolate or solve for the variable. We want it to get it by itself on the side of the equation it's on. So here's the algebraic way we do this versus as opposed to the mental math way we did it before. I look on part A and I say x plus 3 equals 9. Because I have x plus 3, what would be super helpful would be if I could subtract that 3 away. That would be the opposite operation to plus 3, and plus 3 and minus 3 together make 0, meaning there will no longer be a plus 3 on this side. So depending on your teacher that you have, which is me right now, they might write this different ways. Because I'm lazy and don't like to rewrite things, I write minus 3 underneath right here. I say I'm lazy and that's why I do it, but I also like the way this looks. The properties of equality say if I minus 3 over here on the left side of my equal sign, I better also minus 3 on the right side of the equal sign. And then I like to draw a line underneath that. Then we do this thing that I think a lot of people find super satisfying. We say plus 3 minus 3 is 0, so we are going to just mark through those. They're not there anymore. That leaves me with just x on the left, because that plus sign wouldn't need to be there either. You could write x plus 0, but that is writing more information than you need, because if you add 0, it's still x. So this would be x equals 9 minus 3, which is 6. Is that the answer we got before? Probably. Yeah, that's what we got before. And if you think about what you did mentally to figure out that you said what plus 3 equals 9, whether you thought about it or not, you came up with that with the idea of subtraction in mind. You had to say, okay, I've got 3 and I've got to get to 9. What's the difference between those two numbers? Difference, by the way, is a word that means subtraction. So x equals 6, and we did that using algebra now instead of mental math. Whoops. All right, let's look at B. So here we have a minus 2 equals 10. So because we have a minus 2 there, now wouldn't it be great if we could add 2? So this is a situation where, hey, wouldn't it be great if we could add 2, but oh wait, we can if we use the addition property of equality. So I can add 2 here, and I can add 2 there, here are 2, there are 2, everywhere are 2, 2. I'm so sorry that I have a 3-year-old and you get nursery rhymes instead of rap songs right now. But I'm not sorry I have a 3-year-old, but I'm sorry that that's coming out in this video. Love you, 3-year-old. 10 plus 2 gives us 12, which is the answer we got earlier. And so I said earlier, as I'm going through this, I'm trying to mimic what I think you as a student should do. So these things I'm writing down, we call this showing our work. And yes, earlier we were able to just write down our answer without having to write anything else out. But by writing these things down I'm showing other people who look at this what my logic was. And so what's cool about this is it lets teachers or parents or whoever is looking at your work, it lets them see if you get it wrong, if there's a good, like, why did you get it wrong? So if you wrote down your work here on B and then said A equals 13, everything else was right, you just wrote 13 instead of 12. Well, that's an issue with, you need to be more careful about adding 2, because 10 plus 2 is 12, not 13. Whereas if all you do is write down the number 13 without any other work shown, then the teacher or parent or whoever's looking at it has no idea why you picked the number 13. The number 13 could have just been a completely random guess on your part, for all they know, if you don't show work. So teachers go on and on, math teachers go, and science probably, go on and on about showing work so that they can help you basically understand things better. And also it makes it look less like you just copied down answers from your friend. So 2 good reasons to show work. Part C. So earlier when we did this, we said this is multiplication. 4 times y equals 20. The opposite of multiplication is division. So we were going to use the division property of equality to divide both sides of this by 4. And get y equals 20 divided by 4. Again, this is essentially the same thing we did earlier. We just did it in our head earlier. When you think 4 times y equals 20, you are basically thinking either about your multiplication tables, or you are thinking, okay, well, I'm basically dividing by 4. So 20 divided by 4 is what? It's 5. So we were doing the same thing, just we maybe didn't realize that that's what we were doing. And then on this last one, which again, for whatever reason, I know that fractions just naturally have a tendency to seem scarier than other things. What's happening when we have a fraction is division. And so if we're doing n divided by 5, what we want to do to get rid of that 5 from the bottom is multiply both sides by 5. And so I left myself a small amount of room here to write times 5. But we're going to use the multiplication property of equality and do it to both sides of our equation. So what's really happening is that this is 5 over 1. And if you remember how to multiply fractions together, these 5s cancel out. And that's why that's the helpful thing to do here. And that means n equals 30. So that would be our answer. Okay, now it's your turn to try. So let's see if you've got the hang of this, or if you need more explanation. And it's totally fine, by the way, if you need more explanation. People get things at different rates. What's important is that you keep with it. What we're trying to do here is we are trying to internalize these equation rules so that they become second nature to us. And that requires you doing enough problems to be able to say, oh yeah, I feel like I've got the hang of this and know what I'm doing. And the only way to know that is to actually try problems and then find out if you're right, preferably immediately instead of having to wait a while to find out. So pause the video and give these a try, and then start the video back up when you are ready for the answers. Assuming that you did what I asked and paused the video and now have the answers, I'm going to go through and show my work and show how we use the properties of equality to get the answers to these. So 7x equals 21. I'm going to say, well, 7 times x is multiplication, so let's do divide by 7 on both sides and get x equals 3. And again, that's totally reasonable if you knew the answer without having to show any work, especially because I think these in particular, if you know your multiplication tables well, are really easy to do in your head. 7 times what equals 21? 3. I know that. No big deal. Let's look down here at b. So a divided by 2 equals 8. So I'm going to times by 2 on both sides of my equation so that it gets rid of that 2. And I'm left with a equals 16. Let's look at c. We have y minus 3 equals negative 10. So since it's minus 3, I'm going to do the opposite and plus 3. And if that's giving you trouble, just know that minusing 3 from minus 3 doesn't make it go away. That's why we're adding 3, is because negative 3 plus 3 equals 0. And that means that we don't have to write a number over here at all. We just get to write y, which is the whole point of what we're doing, is trying to get y, or whatever letter it is, by itself. Now, negative 10 plus 3 involves us having to know how to work with positive and negative numbers. And if that's something you struggle with at some point in time, if not as this video is uploaded, I will have some videos to help with that you should go check out, because adding and subtracting and multiplying and dividing positive and negative numbers is going to be really important to understand how to do, starting in Algebra 1 and continuing on up. So negative 10 plus 3, the idea here is that they're different signs, so we actually subtract the numbers. 10 minus 3 is 7. So in other words, these numbers, if we ignore their signs, are 7 apart. But then where their signs come in is that the bigger number, the negative 10, means that this should be a negative 7. So there's lots of different ways that we can go about trying to understand how to add and subtract positive and negative numbers, but that's really a subject for another video. And then finally D. Again, this could be really easy to figure out in your head. And sometimes when we figure it out in our head, it makes it even harder to actually think about the work that would be required to do it. That if you already know the answer, you may be like, I just don't even know how I would do anything other than what I already did in my head. And so in that case, we have to just sit and think about what's happening here. 5 plus n, those are being added together. And so I want to find a way to make the 5 go away. So I will subtract the 5. And because I want to do that on both sides, I maintain my equality. 6 minus 5 is 1. There is one other thing that I want us to look at on this video that is loosely related, and that's this idea kind of from the warm-up that we can take words and translate them into math, and we could also do that the other way around as well. Okay, here we have a table that shows us some words that we normally connect with the different operations or symbols in math. So addition, the common ones are plus or sum, S-U-M, but also the phrase more than can also tell us to do addition. Subtraction has minus, difference, and less than. Multiplication has times, as in 7 times something. Product and of. Division, divided by quotient. Ratio, which I really don't feel like ratio happens a ton. It feels really weird for me whenever I try to put it into something most of the time, so I did do that, as you can see on number 3 here, but I don't think that ratio comes up anywhere near as much as these other words. And then to show equality, we really tend to use equals or is. So we're being asked here, can you write the following words as an equation? It doesn't ask us to solve the equation, it doesn't ask us to say what the number is, it just says, can you put this in an equation instead of it being in words. So a number plus 5 equals 12. Well, we've got plus, which we know means addition. We've got equals, which we know means an equal sign. 5 and 12 are numbers. So really it's just, what do we put for a number? Well, we're going to put a variable, and that's what's going to make this an equation. So a number, I can pick whatever letter I want, but since it says a number, I like to pick N because that's the first letter of number. So a number plus, so I put plus 5 equals, and then 12. What's really cool about this is that typically things go in the same order as what they are in the sentence. The only one that you really have to be careful of is less than. Less than is actually a thing that turns it around. More than technically does as well, but addition can be done in whatever order. So less than is a bit tricky to work with, but all the other ones, it's in the same order as what you would normally have. So that's helpful. Number 2 says 6 times a number is 24. So we write down the number 6. We say times, that's multiplication. We could put a dot here. I don't recommend putting an X for multiplication anymore, just because now we actually use X to mean X. 6 times number, or we could just put the N right next to it. So 6N is, tells us to put an equal sign, and then 24. And you probably are looking at these saying, I know what N is, I know what N is, and that's great, I'm glad. It doesn't ask us to do that, but I'm glad that you know what N is. The ratio of a number and 4 is 7. So ratio is a word that means division, or it's also a word that means you have a fraction. And so there's 2 ways of representing division, technically. You can use the divided by sign, but especially starting in algebra and going up, we use the division symbol much less, and we usually prefer to do fractions. So the ratio of a number and 4, we want to have a variable and 4 in a fraction. So n over 4. And we put it in the order that they gave it to us. That equals 7. So we can see how it's almost like math is its own language. We translated English into an equation, and so that word translate, has to do with languages. There definitely can be times where, for whatever reason, you might feel like your teacher or somebody else that's talking about math is just speaking an entirely different language from you. And so it's things like this that help to bridge that gap, that these words have a direct relationship to math or vice versa. So, alright, now I've got a challenge problem for you right before I wrap this video up. I want you to think about this, and it's going to directly lead into the next lesson that I put up, which is solving 2-step linear equations. So think about it and see if you can come up with the answer to this. The sum of 2 times a number and 7 is 11. What is the number? Take as much time as you need. If you think you have the answer, feel free to leave a comment below. Or if there's anything in the video that you didn't understand and would like more explanation on, leave a comment. If you just really want to say hi or brag that you're the first person to comment, that's also acceptable. But definitely let me know what you think, and I look forward to continuing this Algebra 1 journey with you. Hey, thanks for watching all the way to the end here. There is one more thing that you should probably do at this point, and that is practice the skills that were in this video. So I've got a couple options for you. Both of them can be found at my website, KStevMath.com. The link's in the description to get directly there, or you can use the web address on the screen right now and navigate to Algebra 1 and to one-step equations and go through that whole process. Also, a really cool thing I'm doing starting this fall 2020 is a online Algebra 1 course, so you can actually take Algebra 1 with me online. If you're interested in that for yourself, or if you're a parent and you're interested in that for your kids, please head over to my website and check that out as well. It's important to practice math skills, so I've got a nice little app that generates problems and answers and will also give you some help along the way. I've also got a practice sheet that you can use, and just so much more. I'm adding more to the website every day, or at least trying to. So again, thanks for watching. Please feel free to like or comment or subscribe or all 3, and I'll see you in the next video.